lead the discussion. Over to you, Bhushan. Thank you.
Good afternoon, everyone, and welcome to this, the last session in this year's conference on electric mobility, and we are honored to have three speakers on board. We have Mr. Sujit Mishra from the Northeastern Railway, Minister of Railways. We have Mr. John Wood, who is the CEO of ECOL, and Mr. Sajid Mubashir, member R&D with the National Automotive Board. Interesting session. I know it's always a challenge to do a session right at the end of the conference, and we are anyway running short. So what we'll do is we'll keep it short. We're going to do about, say, 10 minutes each for 3 presentations, so that's going to take us half an hour, and then try and do about 5 to 10 minutes of Q&A. I think that's how we'll try and do it, and without extending this any further, I'd request Mr. Mishra to kindly start with his presentation.
I'm Sujit Mishra, I'm a railway man, but I'll be essentially talking about rather my talk would have a bias towards the grid, and it's not a short presentation. These are just the thoughts which we feel can be discussed further because this is a panel discussion. So it's, I try to title it as thoughts on grid and e-mobility, because these are the two very evolved different sectors which have to now work together. And there's a lot of path dependence because there's a legacy overhanging in both these sectors. Now, how things happen. It may sound counterintuitive, but electric mobility is a 19th century idea, and the grid is a 20th century idea. If you look at electric boats, the road vehicles, locomotives, they were all there by late 19th century. However, by 1920, the road vehicles electric road vehicles conclusively lost to the chemical energy of liquid fossil fuels, and we had internal combustion engines. It was about the same time when the grid emerged. It's interesting to note that in 1912, if I'm not wrong, about 30,000 electric road vehicles were produced in the US, whereas this figure is slightly more than the number of electric vehicles manufactured in the US in 2002. Still in mainstream, if you look at the electric drives, you have electric locomotion, which gained traction after Second World War. Of course, it was there even before that, but then it became fully mainstream after that, and it is still there. The technology is now really evolved, it is now mature. Diesel electric drive again got traction post Second World War. Now it's a mature technology for rail, mining, marine applications, and submarines from day one continue to be on electric drives. Grid, as I mentioned, is a 20th century idea. I won't get into much details, but this is an interesting thing which I came across. I thought I'd share with you that in US in 1900, 40% of road vehicles were running on steam, 38% were on electricity, and only 22% were on gasoline. And the car which you see here in the picture was manufactured in 1884. The drivers of change, if you look at the mobility options exercised by our society, then that is in 20th century, was that the storage actually lost out to the superior chemical energy, which was considered to be more potent. The issue of range anxiety was addressed partly because oil emerged as the new gold, and the entire global economics and politics started turning on the pivot of oil, and also had a different dimension, and it gave a sense of personal independence. Now, the key driver of change in mobility is the existential threat which we face by way of climate change. The direct dependence on a particular type of primary source of energy is not increasingly recognized by the governments as a key strategic impediment when we try to cast a scenario for us the way our countries evolve and develop. Also, one of the key drivers of change which is now being identified is that the technology is fast maturing. If you look at the grid in its management, in its mathematics, especially on the distribution automation side and in the distribution management side, and the computation power which is now needed. And briefly touch upon it, that there is now a thought of something like a mobilization of grid, which needs to be done on the distribution level, at the retail level, if you really want to harness the storage capability of electric vehicles. The drives have now matured from late 70s when the first semiconductor drives came into meaningful application. Now we have far superior, more efficient semiconductor switches. see the grid today, like there was a talk I believe the speaker from Mitsubishi was mentioning that the day our grid evolves and is strengthened. I'll talk more about it. That's actually a misnomer. That's actually a misnomer. The way we have cast our grid, and it is depending upon few but large generators. This is the way the present grid has evolved, and this is what actually strongly casts us. We are cast in that mode that we need to have the whole grid is designed about few generators but large generators. And if you look at the distribution and the consumption, the other end of the power value chain, it's not designed for bidirectional flow of energy. And even the things like time of day metering, something like Samuel himself saw it in England and brought it in US in 1904, it's still to be implemented in most of the markets, even globally, let alone Indian market. Major breakthrough happened in the metering infrastructure. The initial aim was just to do an automated meter reading. And there are large-scale simulations of, say, a citywide distribution network which has bidirectional flow of energy from the customer premises. Say, for example, typically a large commercial entity like a mall, a big mall which has a large air conditioning load which starts to interact with the grid. So it's not just the megawatts, the active power which flows, but also the negawatts, or the absence of demand, or the demand which you deny as a user, or the requirement which you say that, okay, I will not consume this. That is termed as megawatt. So today we have what we call as a gridded grid. So when we talk about sometime tomorrow when the grid strengthens, that's actually a misnomer. And the concept of a brittle grid, this phrase was coined by a maverick heartbreaker who came about and who challenged this conventional way the grid has been understood and is even taught in the engineering schools. Is that it is based about small number of large generators. So in 1982, of course that concept he wrote in a foreign policy magazine in 1976. In 1982, he talked about a term, a phrase called brittle grid. And brittle grid very aptly describes the grid which we hope is going to strengthen. So what we are actually doing is we are increasing the brittleness of grid the way we are trying and hoping to strengthen it. And there's a very interesting case study. I just read it in September in Energy Wise newsletter of IEEE Spectrum. That golden blackouts in these winters in Belgium, which has a very stable grid, has a very stable political system, they have been planned. After Dover power station near Antwerp, the reactor number 3 and the reactor number 2 were taken out because of micro cracks in the steel plates of pressure vessel, reactor pressure vessel. And then, exactly what American Robbins wrote in 1982, reactor number 4 had to be taken out because of a possible internal sabotage. Now, this led to the country depends almost for 25% of its power on nuclear reactors. So, as they plan to have rolling blackouts to meet the peaking demand in the winters, is it just the outcome of this? Now, remember, this is a very stable society, very stable and mature political system. And I am just quoting from Energy Wise newsletter from IEEE Spectrum. And I am just highlighting the key points. The response, as the magazine says, uses the words like explosive response, recrimination by elected officers, questioning the fairness, and also the national favoritism. Now, this is what actually happens when we are looking at the so-called, the strong and the stable grid which even our country is aspiring to have, when it takes out a few large generators. Now, I'll come to the last slide of my presentation. Now, what is the way ahead? And as I said, that since this is a panel discussion, I just try to put together the ideas on which the future developments in mobility and in energy sectors they will move about. The electric vehicles are not just attractive per se, or they are not just good for being clean and environment. It is actually a very important dimension in our energy security, and it's actually a very important dimension in the stability or the security of the grid. And that dimension now needs to be fully explored, because that adds to that weighs very heavily when we make a business case for electric vehicles. And in fact, the baseload transportation, this is what one of the documents, railway documents in the European Union says that they need to, since the transportation has to move, the baseload transportation has to move on to electric. Sorry. And one of the first things which you can possibly do is to move the fleet operators onto electric vehicles. Electric vehicles, these are small retail, small size storage elements which are moving in the system. Unless we have something like demand aggregators in place which are able to capacity which is offered all over the place in the system, something like what we call, or what we came across in discussion as an organized grid. These modules can really smoothen the demand curve and provide for active-reactive fast support, that is ancillary services. We need to bring the change by way of legislation. Possibly Dr. Sajid would be able to possibly talk more about it. Change by way of legislation where the fleet operators can be obliged to run the fleets of electric vehicles. And another interesting thing is that there are about 350,000 telecom towers. There was just, I think, a speaker in the last session mentioned about. These telecom towers are all equipped with excellent storage. And as government is spending more money in taking electricity to the places where these already invested in infrastructure and is already put in place, there is a possibility of creating a business case to harness the storage which is already embedded in our system. So, and lastly, one of the things which again I believe it was discussed in one of the discussion presenters earlier, there is an issue that electricity per se in our federal structure is on the concurrent list, which is governed both by center and the state. However, the taxes on electricity and the way we sell it is decided by the state governments, and that's where a lot of issues start to come about. So, with this, I'd like to end. Thank you.
Thank you, Mr. Mishra, and thanks very much for sticking to the time. Important points that you made in your presentation while talking about EVs, which is indeed a strategic dimension in energy security. We are going to talk more about that, but right ahead we move to Mr. John Wood, CEO of Eco. I believe we need to get the laptop back on the day. Oh, where's the president? Slide changer? Do you have the slide changer? That's it.
All right, thank you very much. So earlier in the conference I presented in the stationary forum talking about these ultra batteries in stationary. What I want to do is talk about mobility now. Now, since it's late in the day, excuse me here because I might ad-lib a little bit on this for you. I look at it this way. East Penn is the parent company of Eco in the USA, and we make about 30% of the automotive battery and the motive batteries that are actually deployed in the USA. I was once rambling on about energy storage to a senior executive at East Penn. We were driving back from Washington, D.C. to Pennsylvania, and they said to me, look out of your window, John, there's a traffic jam and there's thousands of cars and we're in the middle of all this. And they said, take the cars divided by 3 and there's an East Penn battery in every one of those 3. And now look at the trucks, and you can take 2/3 of them and you can count them by 6. And we're sort of putting everything in perspective for me. And so the way we see this in the battery world, you can see that starter battery up there that's used in your car. That's like, in terms of teaching an old dog new tricks, think of that starter battery as being like a Labrador. It's reliable, it'll bring you your shoes. You can trust that it's going to start your car. So who's got a lead-acid battery that starts their car in the audience here at the moment, right? So we all know and rely on them. That guy there, the motive battery, it's like the Husky. It's the one that drives the forklift. But think of it as the big dog with the big shoulders that manages to bring the loads along. And then we've got the standby batteries, which is to me like those guard dogs. So if something goes wrong, all of a sudden all this energy jumps in out of this lead-acid battery to keep everything running. But somebody said you can't teach an old dog new tricks, but I know something about old dogs, and that is they all once were wolves. And so the wolf in the pack is ultra battery. That's where you've got to think about it. Ultra battery loves to run and run and run. It loves to run in a pack. So now I'm putting it in terms of the automotive world and thinking about the scope of all those cars out there that have already SLI batteries running in them. So working with East Penn and with Ultra Battery, what we've been doing is introducing start-stop type features, and also the mild HEV, where we boost the power chain with regenerative type power coming from the batteries as well. This is the rollout profile, and this is what a battery sees when it's inside a regenerative application in an automobile. Now, you probably all graphed out from the number of graphs we've all put up through the course of this conference. So this graph looks just like the other graphs, and what you're seeing is a whole lot of variability going on and the battery being given a hiding. And you see a lot of these as well, which basically shows how the batteries significantly outperform. And so this is what we're doing with ultra battery in a motive context. And this particular profile here, this is a start-stop profile. So when I presented yesterday, I talked about how we can take an ordinary diesel side and we can make that diesel side more efficient. A lot of people think about batteries and diesels as being opposites. If there's one message I can get across in this conference for people to start thinking about in terms of energy storage, it'd be this very simple one. The best place for a battery is right next to a diesel, or a petrol engine, or any sort of spinning engine, because the two work together like magic to make things happen very efficiently. So you can take a battery and a diesel and you can achieve the same outcome in a telecom tower by using half the amount of diesel. This is really all that's happening when we start to put the batteries in the cars working with the engine in the car, and we start turning the engine off and turning it on. So the major impact, the first major impact you can have in a mobility type sense of energy storage is through this start-stop type profiling. Now, this is another one of those great graphs. And what this great graph shows you is that this is a VRLA battery, the best that we could make trying to do this job. And here's an ultra battery doing it better. I'm going to keep it that simple for the purposes. But bringing it down into a few numbers. Against that profile, we don't measure ourselves against lead-acid batteries. What we do is we measure ourselves against alternative chemistries. And you can see here that against nickel metal hydride, we outperform nickel metal hydride in that particular application. And down here on the Eurocar profile, so this is a medium HEV profile in Europe, it might surprise you to see that the ultra battery actually did twice the number of cycles of the nickel metal hydride, which was the standard battery used for that purpose. And so here's a couple of cars, automobiles that now are using ultra battery that have done more than 160,000 miles without battery replacement and without those batteries being refreshed. All that's happened in this case was that the nickel metal hydride pack was taken out of the cars, they were replaced with ultra batteries, and they were driven without being refreshed continuously. Well, not continuously, because people stopped driving the car, but they were driven for a long, long time to get a number of miles. Now, when we're talking about lithium, one of the things we talked about was that you need little microprocessors on each battery to do the battery balancing. One of the things we don't do is battery balancing. And so I put up this graph, this is one I like. And you can see this was, the blue line at the top here is the high voltage at the start of life of the highest voltage cell. The red one is the lowest voltage cell at the start of life. And this is after the same pack has been driven 45,000 miles. You see that the batteries have actually come together in their voltages. Now, there's no active battery balancing going on there at all. That's just happened. So, I've had a journey in the energy storage industry. It's been a lot of fun. I used to be in the security industry and in the payments industry, and did some things with smart cards. But along the way, one of the first things that happened was I started to work with the Department of Energy in the US, and in particular with Sandia Laboratories. And that's where the first real recognition of the outperformance of ultra battery and variability management came from. And that's when we started taking on alternative chemistries. And so against this profile, you can see that the ultra battery outperformed not just VRLA by a factor of 13, but we also outperformed lithium ion head-to-head on this particular test that was done at Sandia. Well, we didn't stop there, and those test results now we've more than doubled with this new chemistry. So I think I've got one thing to say on that, which is sort of game on, guys. You can teach an old dog new tricks, and you can do some pretty spectacular things with it. This diagram shows you a little bit about works. Now, it's a complex picture, but I'm going to tell you what it is simply. This is the charge acceptance and the discharge acceptance of the device. This is not a battery, it's not an ultracapacitor. It's a battery and an ultracapacitor in a single electrolyte that has hybrid characteristics. The ultracapacitor is not there to store energy, but rather to modify the behavior of the battery chemistry. And so an ordinary battery on this profile is that blue line. See the blue line that sort of has a little low bit here and it goes up the top. And then a capacitor would be this sort of yellow line through the middle. But what the ultra battery is sort of a pumped up battery. So it has great charge acceptance, great discharge, and it cycles like a wolf. So it's an excellent technology. I put this graph in the pack so that people can look at the efficiency that we're running. The efficiency is rate dependent, and this particular efficiency graph is for a large format battery. We also have small format ultra batteries that we cycle it up to 20C. So that's 20C charge acceptance, 20C discharge. Another way of saying that, it's about the rate that you can fill the battery in about 3 minutes, or discharge it and charge the battery in about 3 minutes. So it's an interesting technology. Interesting technologies are a lot of fun, but one thing that's important is that they're built on foundations of sustainability. And so the lead acid industry, I was very pleased to see Exide reference the cooperation that we're building around ultra battery. You've got to be able to do it safely, you've got to have a supply chain, you've got to be able to recycle that technology at the end of the day if it's going to be sustainable. 98% of every lead acid battery is recycled. Thank you very much, and happy to take any questions.
Wonderful. Thank you very much. We would take questions at the end of this session, but now, next on is Mr. Sadir Mubashir, member R&D at the National Automotive Board.
Well, I thought it will be flexible, but not without the ability to be flexible about it. It's a HTML presentation. So I think we'll go to this second one, NMEM. See, I think this might take away the attention. Basically, I'm not trying to talk about anything exciting, anything outstanding. It should look, my intention is this whole thing should look very simple and not alarm people. So that's the idea. The issue at stake is how do we, what we're trying to address is this transition from the transformation energy. It was said that from carbon one moves to hydrocarbon, and then it was expected finally it will be hydrogen. The path seems to be a little different. It's now petroleum fuel to an electric paradigm, but anyway, kind of an extraction. In our case, we have 4 legs. I think, can you go to number 2? Click on that. Yeah, and then click one by one. So this thing here, you can scroll up and down. This yellow part, you keep scrolling down. Can I do this? Okay, that's fine. So the objective is, the first objective is not about carbon dioxide reduction, that is an incidental. We are looking at the energy security. I've written the fossil fuel saving, but it's more like energy security in the long term. It's about behavioral changes of the entire system and investments for that. So all of those things which we'll talk about now, it's an investment for future. Though in our presentations here, we will talk about a program for 2020 and what benefits might happen in that period of time. Along with that, this issue about the strong manufacturing sector here, and the manufacture and the sale of affordable EVs in the country. This is the theme. And concurrent employment generation. I'll go rather slow because there's a lot to say, a lot of slides, but I'll stop when we are at 10 minutes. And it's an industry, academia, with a government collaboration for the infrastructure, for the consumer awareness, and the technology part. But all said and done, we have a plan here. Now suppose, for example, Chinmay was here, he talked about a hybrid solution which doesn't need all of this. People might dispute what kind of hybrid that is, but it does give savings. So if there are solutions like that going to come up, or companies are going to come in with solutions like auto batteries and things like that, very good. But if they don't, then you need this plan. So that's the idea. More further. Yeah, keep going. We keep going slowly. I'll adjust to that. So essentially, the mission is about creating a small market, the minimum market which we think. We developed for 2 years before we kind of came out with this plan. The idea is if you can have about 6 to 7 million vehicles. And don't get alarmed, 6 to 7 million of vehicles, like what people are possessing today. So that means 75% would be two-wheelers, and then things like that, and then buses and cars and all of that. So all together, we talk about 6 to 7 million, and we have kept aside a provision to enable people to purchase it. Person going to the store should get, so that's the essential idea. So with that, we can say by 2020 it is potentially possible to have the kind of numbers you've shown here of fuel savings, all of that. But that's still, one must take it that it's just a seed. We're talking about 2020, we don't get too much stuck on that number. There is not much of a choice we exercise. So it's not a driven program. Much of the opinion would be that why don't we drive a program to a particular level. For example, plug-in hybrids are the theme in the United States. EVs, I think France would go with EVs. Many companies have with EVs directly. We have left it open. We might move along. We might change the plans along the way. But there are 4 themes which we work with, which is there everywhere if you look at it. Any advanced country you look at it, the program is essentially 4. There is a demand creation, the domestic demand creation. All of these initiatives you have, any country you take, it's about their domestic market and seeding them. So later on, of course, they get ability, they can go out. For that, typically, consumer incentive of some kind. It could be tax rebates, large tax rebates, I'll come to that slide later. And then a supply side incentive, people fund their companies for technology and the supply side creation. Creating a charging infrastructure, there are major programs across the world, and we would do most of it in a shoestring manner. For example, charging infrastructure is something I think we just show the example, and people should be able to set up shop themselves. This is one of the things which we pursue, and of course the technology development program, which essentially is if we are going to catalyze this market and all of these things till 2020, then at 2020 we need to wean off this program. And that weaning off is possible only if you have a technology program which runs concurrently and develop the option so that you can kind of stop the subsidy in 2020. The rationale, take this with a pinch of salt in the sense like, if all of that happened and by 2020 this kind of numbers get sold, this can be the benefit, but that's not really the benefit we're looking at. We're looking at long-term change. We're looking at behavioral change in the entire industry, about the consumer, the transportation paradigm, and eventually, in the very long future, say for example, why not generate electricity on the road? It's the road assets. On the road, on sides of the road, we have solar power here. So all of that. So this is just a path we're kind of cutting into this area. This program brings it to many other existing important initiatives. Make in India, of course, the latest and the biggest one here. National Transport Policy and all the other ones, many of them which you fit in very nicely. You'll have to go back up, right up. Excuse me, yeah, I thought I could kind of move around flexibly. Anyway, the next one. Well, just scroll it down. This is basically the benefits. I'm at 5 minutes now. Just go down. Keep going down. Employment generation, all of that. Then you can go back up. Global survey. Just to say that it is nothing new. That's why I said it should not be a new thing which is appealing to you. So you see, like, just scroll down. There is Japan there doing all of the same thing. China, numbers are big. Chinese ambition, look at the number, 15 billion they're talking about in R&D. And, everything is in billion in that side. Going down, US, of course, large number, $7,500 as, of course, it's tax, paying the tax kind of thing. And a lot of research funding directly through this, through the regular programs, through the SBI program, huge amount of research funding, directly going to companies as well. France is a leader. If you want to see that, you look at the number of charging points. They are really leaders in this area. Anyway, the largest number of EVs sold in the world is the Nissan Leaf. Of course, it is Nissan, but still, it's a lot of things coming out of Renault. Go back. Indian situation, we can just leave it. We're just saying that people are capable here. we have the confidence that we can do things. Target timelines could be something of interest to you. Just go around a little bit. See, this is the way we hope this program will go. A moderate push, just might look like a more of a management kind of a thing which we're talking about, and that's what it is. How do you manage this whole program, this transition? It's about, initially, since we don't have too many vehicles, people are building up capacity, products. So to get those vehicles which are already out there are some vehicles. Reva is the oldest, many two-wheelers, people have made 3 and 4-wheelers and all transport. All of that, let's get it out on the road, including, the retrofit and all of that. Charging infrastructure, there we should pay attention, because just kind of dwell on this topic a little bit. This is very strange that the electric vehicle supply equipment, that is typically in an AC charging situation, you have a charger on board, and then you have all of that which connects to the supply line. That part can cost $5,000 at one end, or $1,000. Now that will be the cost of vehicles in the country. This won't work. We need to do something else. So we have a fresh thought on that, what can be done. And then of course the technology platform, which is what I really want to talk about. Maybe when we sit down. So finally what we need to do, this will happen. Let's go back up. Come to technology platform, number 4. Yeah. So, rest of it we can talk about. This is creative. And I think this is what I'm directly involved in as well. How do we do this, Because we really don't have a precedent in terms of civilian R&D producing anything much. Defense R&D, DRDO, that's a sad story, they do a lot of things. But certainly, space and atomic energy have delivered big time. Really big time. So we have done, and this is propelled, all the self-propulsion to reach real global heights. So we don't need to talk too much about it, there is ability. And there are people who are capable. And software can be called, some software activity can be called real technology activities, So this intellectual creation there. What we're looking at here is a cost sharing program where about 1,000 crores to be spent by the government, because the industry is promising about 1,000 crores. And then ways of putting things together. Consortium is a new thing for us. We don't have many, but I happen to have run a small consortium program here, fair understanding. Essentially, there is a big gap between the academic, what the academics are interested to pursue and where they would like to leave the topic. That is, if once academics find a solution, they are no more interested in that topic. But till then, they're very much engaged in that. Now, between that and what the industry can pick up, there is a big gap, and it's always in a question of debate. We think there could be things like the centers of excellence. Well, a good example could be what the Fraunhofer is like in Germany, or there are such chains across the world. But so essentially we are talking about the mission starting out with 4 or 5 things like feature verticals, and then infrastructure for the R&D and technology development, plus this new thing that industry would drive the technology programs themselves, consortia led, and with participation by other industry. Hopefully that can happen here, because anyway the auto industry is like highly structured and a lot of interlinkages there. So this is what, when my time is getting up, I'm from the National Automotive Board, that's the last one out there. It's a new creation, I'm only employed right now. So I think we have to talk a little bit. One more thing, I'd like to point at 4A. 4A, and those 3 I think I'll just show, I might run out of time, but still. This is the Department of Science and Technology is assisting this effort, which is coming out of the Department of Heavy Industry. Come down. They made 4 groups, very obvious: systems integration, energy charging solution, power electronics, charging infrastructure. Come down. See, this is the kind of thing. There's a large group debating on. So this is an assistant from Science and Technology Department. Next one, go back up and tells you the other one, 4B. 4B, yeah. Right. So this term technology platform we have taken from the 11th plan document of planning and leasing. Didn't get implemented, but things keep rolling, but we have taken this up. We are saying there could be these 6 items here. Just lift up a little bit. So that's what I need to say. So we are hoping to have these lines out there implemented as technology platforms. Now the word platform is deliberate. It means a lot of people, and it may mean many things to different people, but a lot of activities in these areas. Systems issues are there, and there are specific components to develop a particular Indian situation, which of course is cost constraint. That's one of the major things, but it's not just the cost. There are many other issues involved. Solutions are brought. It's not a cliché to say that you can't just run things out here. There's a particular environment here, and the technology program will run like this. This is not about the technology program. The talk is not about technology. It's about how to manage this whole thing. And I hope it isn't sound very alarming. It sounds very simple, doable, and prosaic. And that's the intent. Thank you.
What I'm going to do is I'm going to stand up. It makes it a little easier talking to the panelists. Three wonderful presentations. And since we're already at 5:45, I'll probably just keep it about 5 more minutes. One question that comes to my mind for Mr. Mubashir and Mr. Mishra. What are the crucial next steps? I mean, you did talk about technology platforms. You did talk about an industry technology consortia. Are there collaborations possible between what you're currently pursuing and what Mr. Mishra said, and the kind of experience that the Navy is already offering?
So what did Mishra say?
Like what I mentioned in my presentation, one of the key stumbling blocks are actually is the vehicle is going to interact with the distribution system.
Can you have the mic on, please?
Yeah. One of the key challenges for us in our country is any electric vehicle is going to interact with the distribution layer of the power system. And this layer rests with the state governments. And the state governments, the condition, the state distribution utilities, the condition in which they happen to be in, we are not really very enthused. So one of the key challenges which as government we have to take on is to do the much promised reforms, much delayed reforms in this there. So the next possible step, I believe, is not in space of technology, has to be in the distribution systems. Make them a bit smarter, we can work with it. Because as of now, as the things stand today, the challenges are two-pronged challenges we face. Firstly, at the distribution level is they are plagued by severe financial stress, and another is the real transmission network, which rests with largely with the central government. It's part of what Lovins called as the brittle grid. So the talk that we don't need energy storage when the grids get strengthened is actually a misnomer. We need energy storage elements embedded within the system to give ancillary service support and give support to the grid. The grid doesn't just collapse because there is not enough active power generation. It also collapses when it doesn't have reactive power supply. So these are the kind of things which can only be given by storage solutions which are interspersed in the system. And if you look at the other end of the network, which is the distribution side, if we are able to somehow deploy the 350,000 telecom towers and the storage elements which are built into it, I believe we can have really a very good local ancillary power support, especially on the reactive power side, which can really improve the distribution system. And that in turn can give a lot of encouragement to people to strengthen this way.
Thank you. Two key points that I know that you have that in mind. One is about microgrids, the possibility of pursuing that area, and also the concept of nest manufacturing, especially when it comes to battery and battery cells within the NME program.
Let me just take on a little bit.
Sure.
You see that there is this issue about, a lot of issues come up when you aggregate. Grid is a very aggregated system, and I don't really understand that. But there are things which happens at the very local level. For example, where does the grid fail? In this context of a lot of people coming and charging in the evening after coming home, the failure would be the local power, local substation, which is just next door to the corner. So that's one issue. Second, of course, is that so from the EV point of view, we need to worry: do we get those charging points where we want? That's one thing. But while you charge, you're kind of transmitting disturbances of grid. But my take on this is that we should look at a little bit more of decentralized management. I'm not sure whether the grid is meant for that or not. But since the problem is local, perhaps the solution also should be found local. So of course, one can look at the countrywide population of electric vehicles and say that's a huge bank out there of buffer, all that is fine, but there could be a solution at the local level, at where you're drawing the power and, for example, one of those things which we want to do, two things we want to do with electric, with the charging infrastructure. One is to simplify this whole thing about the definition, the different consortiums, the competing ones. Standard agencies competing among themselves is a very interesting thing to observe. There are, SAE and IEC and Japanese and big competition. So we are kind of not going that far. We will say till the REVA class of the vehicle, we could just manage with the industrial plug, which costs about 400-500 rupees. That should be adequate. Industrial plugs are quite safe, they use the industries, but of course the communication part is not addressed. We could address it separately. So we're looking at that. And vehicles above that, we could simply take the Type 2 and be done with it, nothing more. There are of course many definitions. We won't be bothered about that. Because if they're going to cost $5,000, that's not for us. Second thing is about stringing up fast charging stations. The reason is people may not be able to charge at home just because you may not have the parking lot and the power plug around nearby. So the responsibility of operating the road with charging stations, normal, regular, and large number of public charging fast charging stations. The government is taking on that responsibility, but in a different mode. Like we will try to kind of catalyze afterwards. And fortunately, the Indian grid, the basic plug point with the three-phase connection is adequate even for fast charging. There is only one difference. Our vehicles will run at 48 volts, 72 volts, so fast chargers are a different category. So that's about that. Second is, of course, the way to make, we talk about nest manufacturing, essentially about how do we bring, batteries like you talked about, how can we make it here? Because it's not about localizing of manufacturing, it's about bringing the cost under control. And batteries are big cost. So one way we thought is that we will simply reduce the cost of the size of the battery. The price will come down. By providing enough charging stations, people should not get worried. And a means of charging quick enough that you don't get too hassle. So that's a combination. In every class of vehicle, we'll try to push the vehicle. That will be one of the intent of the technology platform. Push the size of this big thing which you carry around. It is heavy, it's expensive, so we should do less with that. And along with that, we are also attempting to, currently the group is working, the three things we work on, standardizing the charging infrastructure from our point of view. We are not competing with any international standards, we're just adapting them to our purposes, we're selecting them. And even the industrial plug has got IEC number, so that's not a big deal. Then, one thing we would like to intervene, which has not happened anyway, is to try and standardize something about the battery. And potentially, we think it is a module, which is of not too much concern to anyone. The battery pack would remain the same, but we are attempting to make some specifications of modules. Cells make a module, modules with the pack. The pack you can have the way you want, but we like to standardize the module to some extent. So some vendor can make large numbers and it can fit to many classes of vehicle.
Thank you. I have a question on the, Mr. Gubati talked about the cost aspect. So when you talk about the batteries, compared to what the solutions that have been talked about globally, how does Ultra Battery compare in terms of cost? And
Really well.
yeah.
Can I just pick up on the local solution? First of all, when you think about electrification of mobile assets, cars, trucks, trains, let's look at cars and trucks. If I want to make a full electric vehicle, I need this many batteries, quite a lot. If I want to do start-stop, I need about this many batteries in comparison. And the point I'm trying to make here is that if you can take 3 vehicles and make them start-stop vehicles, you'll get the same fuel efficiency as if you take 1 vehicle and make it an EV. So when you think about local solutions, what I'm trying to say here is, all right, we've got 3 of these things instead of 1 of these. And so the bang for the buck for India of introducing start-stop into locally produced vehicles is much higher than trying to aspire straight away to an EV program, a full EV program. The second thing I wanted to say about think local and act local. And that was that factory was making a lot of household UPS systems, a lot of small UPS systems, which are, you know, a uniquely Indian thing. You've got this massive asset all over India, distributed asset, where people have got UPS systems today. Now, they're already connected up. If you could find a way to make those assets usable inward for the house and usable outward, then you won't have a brittle grid. It's uniquely something that India could take up on. All those batteries are actually distributed through the Indian economy today. So, you know, hey, I'm not from India, so I don't want to like give advice on this or anything. But it just seems to me, come in and have a look. The solution is in front of us here in India. If you can take that UPS asset, make that asset that people are investing into their houses, give them some form of getting some form of remuneration for allowing that asset to be used to make the grid less brittle. Much easier to do that than to try and do it for an electric vehicle. Much easier to reach out in that. And so that's an India solution for India. And yeah, I mean, hey, we can transfer technologies to guys like Exide, and they can make the product in India using vehicles.
Wonderful.
Transition to electric paradigm, it's not really a transition from petroleum fuel to electric. There's something more. It's the ability to regenerate. That makes a bit different. Otherwise, there is no sense. The maximum benefit happens in urban areas, and that's primarily is the ability to regenerate from the brain energy. Now, what happens there is the battery is not able to handle the consumption. I think there is potential here, perhaps your solution and things like that. Lithium-ion battery can to a large extent. So that's the key. We need battery systems with a low cost, which can absorb. Now, how big it is doesn't matter. You just need to kind of sufficient size and sufficient so that it absorbs all the energy back as it comes in, the breaking energy. That should be sufficient for so the base thing. That's it.
On the point of regeneration, if you look at the trains, the new locomotives can regenerate. If you look at a freight train, it will regenerate about 10 to 15% of power energy which it consumes in a complete typical run of say 600,000 kilometer run, which is a typical run. And if you look at a metro application or a suburban application, which say 2 kilometers or 3 kilometers station spacing, it can regenerate as much as 30% or 35% of energy which it has consumed. So the electrification of transport infrastructure, like he very rightly says, that the real benefit you get because of this ability to regenerate. So in railroad sector, it is already an established practice.
There is one more thing from what Don said that kind of slipped my mind. I think there is a lot of power. Our technology forum, the tag we talked about, they said this is what we need to work on. So when you talk about the home inverter, there is a technology issue as well. So major focus on power electronics of all kinds, transiting to more sophistication, micro and all that is there. But in terms of solutions, in terms of the management of things, I think that's where we'd like to do a lot of focus.
Okay, I think we have just one, maybe just one question from the audience. Do you have any questions to any of our panelists?
I am from Reliance Solar from Pune, because you are not talking about the PV, photovoltaic solar, for the charging these batteries for the electric vehicles.
Me or? I think it makes things rather simple. It's a DC device, the battery. Solar produces DC. It's a very apt thing, and that's what we like to do. We like to put up charging stations, fully powered, in fact decentralized charging stations, focusing on what we call the roadside Havas and stuff like that for consuming the load, and the EVs. It can be dotted all across the country. In fact, the whole road can be a canopy if you ask me, and generate a self-sufficiency in transport.
I believe we have some examples, a couple of demo installations at Mahindra Reva.
Yeah.
solar photovoltaic applications. Yes, start with you.
Yeah, I have a question for Sujit. Actually, talked about overall ecosystem, but again, one thing is that just Indian Railways itself actually is a huge consumer for electricity as well as actually even diesel in terms of some of the diesel locomotive. But there are again, it's not just about the trains which are running. I think in terms of the overall, I think railway infrastructure, there are so many aspects which are there in terms of railway crossings and other things. Also, there are. So, is there any initiative on the way in Indian Railways, where apart from the mobility aspect of it, lots of other ideas which have been discussed over the last 2 days could be actually very, very applicable for like railway crossings or signaling systems and other things. So just if you can share any light on that.
It's okay. We are the largest institutional consumers of electricity in the country, close to about 10,000 crores or about $1.5 million worth of energy we consume every year. Bulk of it goes for traction, of course. But yes, we do consume a lot of non-traction power also. And much of the assets like signaling, they have to be on 24/7. They are backed by diesel generators. And much of the part, which is in the eastern part of the country, there are places where it runs for almost 14 to 18 hours a day, DG sets. To give an institutional response to this, we have actually set up a PSU. It's called Rail Energy Management Company, which would be doing the projects, renewables, and they would be integrating them. And we would also be entering into power purchase agreements with small renewable generators, the people who are doing that. So this is one institutional response at the ministry level. Another is that we already have, if I'm not wrong, in the last one about three small wind farms, I believe, each. I'm not sure whether it was 5 megawatt or 10 megawatts. That was something like that. We are in process of planning to set up about 100 megawatts of solar. Part of it would be done by us, part of it would be done by REMC, and part of it would be offered to the private sector. So this is all about it. But essentially now, from next year, it would be driven by a rail energy management company. So hope that answers it. And another thing is, we are now investing heavily into regenerative stock. Like Calcutta Metro was the most recent one. It's the oldest metro running metro in the country. So the new stock which is now coming to Calcutta Metro is a regenerative stock. And all new metros which are coming, of course, they are on the regenerative stock.
For the areas where you are running and also using probably the model which Mitsubishi talked about, maybe appropriate. So maybe should they reach out to REMC or who would be the appropriate contact if something like Mitsubishi want to take it forward?
See, personally, I strongly feel, I very, very strongly feel that the solution which was talked about by Mitsubishi, stronger the grid is, more you need such kind of solutions. Because it's actually a misnomer which we try to educate a lot of state utilities as part of the Smart Grid initiative, that a strong, a robust and a more reliable grid is not measured by the presence of electricity by 24/7. It actually, you end up making it more brittle. So if you have to have renewable integration into your grid, you need to have energy storage solutions. Railways, unfortunately, as of now, doesn't really intend to invest into the storage solutions. But I'm very sure that we were working with the Ministry of Urban Development for the metro solutions. Wherever the DC metros are coming up, like we have it in Calcutta Metro, we'll have it in Kochi, we are operating it in Bangalore. The DC metros are ideal candidates for a small scale energy storage. So that's something which they can surely reach out to these three metro administrations.
So, sorry to just push it forward, but just exactly the reason why you said that, because we know right now railway has also some financial issues. So we're not talking about railways investing money, but someone coming in and just providing it as a service and saying that we will basically provide you electricity for the rate which is cheaper than what you're spending on diesel generator. If someone comes in and gives a proposal to railway like this, would railway be acceptable, whereas no investment is required?
Yeah, I understand now. Why I'm not committing on that is that's something which I really do not fully understand, like what the numbers would be. But yes, there is surely a case because we are a very big diesel consumer when it comes to non-traction power. Because all the, the PRSs, all the signaling stations, they need to be backed up. That is one part. But I believe that is going to be still a smaller scale application. But the real interesting applications will happen when you integrate energy storage elements into the metro infrastructure. Because there, especially in the non-lean hours, the grid cannot, because these are unidirectional converters which you put at the substation. So if a metro train is breaking, the system doesn't accept that power. So you in any case have to dump it in a resistor grid. So I believe this will make a lot of sense there. In fact, I believe many applications have already been done elsewhere in the world. As far as I know, Kochi was looking at an energy storage solution. They can possibly get in touch with the Kochi administration. Kochi was actively looking there. We had a discussion sometime back. I'm not sure where it stands today, but they were looking at it. Bangalore has to look at it. And in fact, a very interesting thing will come when Chandni Chowk has this tram application. That also can be an interesting area. Because now that we are talking about, when we say HVDC, we are talking about 800 kV. But if you look at the LVDC quantities, 750 volt DC is a slightly higher DC bus. So if you are running a tram application, if you are running a trolley bus application, say BRTs like I was told that maybe you know that Gujarat was talking about in the BRTs trolley buses. So therein these things will make a lot of sense. Because by provisioning of such elements, your actual traction substation cost also comes down.
Thank you.
Wonderful. I think this has been a delightful panel discussion. I now hand it over back to you. Thank you very much.
So with that, we come to the end of this very extensive and interesting discussion. And as always, it's time for a token of appreciation for the lovely speakers we had. Rahul, if you can please come over, and can we please have the gifts? Mr. Vikanshu Dev Khanna. Mr. Sajid Mubassir. Mr. John Wood. And Mr. Sudeep Mishra. So, Rahul, you just stay back. So before I hand it over to Rahul for the last time, I would like to thank everybody for being here and joining us here at the two-day conference. We come to the end of this. I would also like to thank our principal supporter, Ministry of New and Renewable Energy, and the event being powered by India Energy Storage Alliance, and our organizers, Customized Energy Solutions and Messe Düsseldorf, India. I would also thank our sponsors for this event, the gold sponsor Siemens, and the silver sponsors Ampersaft, Excite, the Salt Systems, Ecolt, SNC Electric, and Sun Edison. Thank you everybody for your time, and hopefully you enjoyed being here with us as much as we had fun having you here with us. And off to Rahul for the last time. Hopefully you had a great time. Thank you.
Thank you everyone. Again, it has been 1 year since we first time attempted to host this event, and again the response has been amazing. We will try to address the issue with the travel time between here to airport so that more people could stay for the last session. So next year we are already planning about hosting the event from 1st to 3rd December in Taj Hotel in Central Delhi, so that it is more convenient for everyone and will get a much larger participation. But overall, I think as the ecosystem, it has been amazing transformation. We started in 2012. At the end of 2012, we had 5 members for ISA. Last year we had, at the end of the year, we had 12 members, so it was almost more than doubling. And now this year we are almost 35 members, and I believe that there are almost around 10 companies during the last 3 days have expressed very strong interest in becoming part of the network. So this is a great participation, and again we need a lot more support from all of you, because we at Customized Energy Solutions on our own can only do certain limited things. We are getting amazing response from policymakers, but again, we just cannot wait for things to happen. But at the same time, I think what Mitsubishi has demonstrated and a number of you have demonstrated is that if you bring in your proposals, the government is very responsive right now, and there is particularly in last 3-4 months with the new government, there is a stark difference in terms of the approach and attitude. And again, I am very personally very positive. I am glad that all of you are here with us, and again, next year when we meet, I'm sure we'll be much further ahead in our journey to transforming India's energy infrastructure. So thank you everyone, particularly thanks CES team and for making the entire event possible. I think at the end of day one of the participants made a comment where that this event has been run wonderfully and it's like a perfect football team. I think that's a compliment for everyone. So thank you once again.